Hello and welcome back to geometry. Today in our class, we're going to be talking about rotation. Before this, we were talking about translation, basically moving your point or mapping your point so that you're moving left and right, up and down. And then before that, we were talking about reflection. So this is going to be the next step then in our mapping sequence. So this definition for rotation is going to be defined as the following then, okay? So whenever you have a rotation about a point O, for any point P, it's going to be a transformation, first of all. So that means that you're going to map the point where P is going to be rotated to some position on the circle with the center where the center is going to be that point O, and OP is going to be its radius. Now, that right there is definitely something that is a little hard to understand. So let's go ahead and look at an illustration to see what that is about. So here we have 2 points right here. P is going to be the point that we're going to be mapping, and then O is going to be our point of rotation. Okay, so imagine what would happen is the following. Let's say that you have a compass. Okay, so let's say that you have a compass where one end, the sharp end of it, is going to be on O, and then the other end is going to be on P. So as you rotate the compass, where O is going to be stationary because it's the pin that's there, and then the pencil is on P, then the result is that you're going to get a circle that looks like this. That is going to be the center of O, and OP is going to be the radius. So on that circle where the circumference is, somewhere on there is going to be the mapping of your point P then. So whenever it comes to rotation, I need to give you the center or the point where you're going to rotate about and how much you're going to rotate that point then. So here, let's go ahead and look at the first example then. Let's say that I want to take point P and I'm going to rotate it about point O by 90 degrees. So again, what that means is you're going to go ahead and draw that circle if it helps you see it a little bit better. And once you draw OP, we're going to go ahead and rotate it by 90 degrees then on that circle. And the rotation is going to be just like the unit circle. So that means you're going to rotate counterclockwise from that point. So from here, OP, you're going to rotate 90 degrees. And that means that point P is going to be located right here then. So this right here is that point that's going to represent when point P is rotated by 90 degrees about point O then. So this is going to be the setup for it. Okay, so that's the first one. Now, let's go ahead and see how that works with another variation then. So let's say that this time around, I want to rotate about point O once again with point P, but I'm going to do an angle that is negative 45 degrees. So with the same circle, I do believe that we can probably, well, let me draw the circle a little bit better first of all. So with the circle, my rotation is now going to be negative 45 degrees. So if you think about the unit circle, then that means we're going to rotate clockwise to this point. So then that means now this over here, that is going to be my position then. So right there, that is going to be the rotation of point P about point O for negative 45 degrees then. Okay. And then finally, now for the third one, this time I'm going to rotate about point P. So just swapping things around, and P is now going to be my center, and O is going to be my point that I'm going to rotate. So for this last problem over here, I'm going to draw a circle where P is going to be the center. So then now that looks something like this. So my mapping is going to be somewhere on the circle then. And since my rotation is going to be 90 degrees, and remember what we said, your rotation is always going to be like the unit circle. So that means it's going to be counterclockwise. So there, OP, we're going to rotate 90 degrees. So this way. And so down here, this is going to be my final point, which is going to be that third one right there. So the rotation about point P, and then for 90 degrees then. So usually the notation is written like this. Okay, so that's the idea behind rotation then. Now, a rotation, just like with translation and also symmetry, is an isometry. So what that means is if you take whatever shape you have, right, and then you rotate it about the point, the result is that you're still going to preserve the shape of whatever the figure it is, okay? You're not going to change like the size of it because you're not, well, making it bigger or you're going to make it smaller. So here, for example, once again, I can go ahead and say point O is going to be my center. And I guess if you want, you can draw kind of like a circle about that point. About that shape that you have. And so as a result, then that means that the shape or the happy face in this case is going to be somewhere on the circle then. Okay, so that's what it looks like. Now let me go ahead and erase some of this right here just to make it a little bit better. And remember that there is a rotation involved. So what that means is if you rotate it, the shape of that the shape of that face is also going to be rotated also as well. So for example, if I say rotate it by 90 degrees over here, then that means that my happy face is going to look something like this over here. And then whereas if I rotate it another 90 degrees to 180 degrees, then that means that my happy face would look upside down in this case then, okay? And then if I were to rotate it back, if I keep rotating again to 270 degrees, then over here, we're gonna go ahead and draw the happy face. And then finally, such that it's gonna go back into the same position then, okay? So the rotation of the shape still happens, but nonetheless, the size of that circle is not gonna change at all whatsoever. Okay, so the last new terminology in the case of in the whole rotation thing is something called a half turn. Okay, so a half turn is defined as the following: a half turn about a point O, which we denoted as h of whatever point it is that you're going to. So h of O in this case is supposed to be a rotation of 180 degrees about point O. So meaning a half turn is just really a 180 degree rotation. Okay, so nothing really changed then. So here in this picture, so if this is my original, then that means that, and here's point O, then this right here is going to be my half point. That's going to be my half turn image going to be then. Okay. All right, so now let's go ahead and look at some coordinates and see how that actually works out with all of this then. So evaluate the following, okay? So here you have a bunch of points on the right, and I want to take them and rotate them about some points that are given to me. So in the first case, we are going to take point A, which is 4, 4, and I'm going to rotate it about point O, which is the origin, okay? And I'm going to rotate it for 90 degrees. So there, what I'm going to do is I'm going to go ahead and draw the circle that C is going to be the center. So then that way I can see where A is going to be located then. So here, let me see if I can kind of draw it without having to butcher everything. So here is going to be my radius. And so my circle is going to look something like this then. Okay, so it's going to look something like this. So looks like if I'm rotating by 90 degrees, then that means I'm going to rotate. And by the way, this is counterclockwise once again. So then that means it looks something like the following, where this is going to be a right angle. Now, since we're on a coordinate system, then it's pretty easy to see where that point is actually going to. So in fact, all of these, you probably want to draw them out so then that way you can see the answer. So looking at the coordinate, the location of it, it looks like it's going to be in quadrant 2. And this guy is going to be -4, 4 then. So that is going to be my answer. There's really no algebra behind this because you have to really visualize it geometrically to see what the answer is going to be. Okay. All right. Now let's go to the second one, which says this time I am going to take point D and I'm going to rotate it about point A by 90 degrees. Okay, so let me go ahead and erase all of these guys over here. So this time I'm going to take point D and rotate it about, let's see, let me go ahead and erase a little bit more, and there we go. Okay, good. So now we're going to go ahead and rotate it, point D about point A. So here's point A, and then here's point D. So point A is going to be your center, where D is going to be, I guess, somewhere on the circumference. So if you were to draw it, then here is going to be your circle. So from there, what we're going to do is we're going to draw the line segment and then rotate counterclockwise so that you get to 90 degrees. So from that picture, it looks like my coordinate is going to be down here then. And that coordinate, we should be able to visualize over here. And it looks like it's going to be skipped by units of 2. So that's going to be 4, 0 then. So our answer is going to be 4, 0. All right, so hopefully, that is, that should be somewhat simple enough for you guys to see. Okay, let's try a few more just in case. This time I want to, and let me go ahead and erase a little bit. There we go, a lot better. Okay, and I'm going to put this over here. This time, now I'm going to go ahead and take point A and rotate it about point C. So then that way it's going to be a half circle, okay? So over there, let's see. I'm going to go ahead and draw AC, right? And then I'm going to draw, actually, let's go ahead and use the other pen. I think it's a little bit easier to see then, okay? For this one, let's see. Let's make it not so thick. Okay, got it. Okay, so here's AC. Okay, so that's the first part. Now I'm going to go ahead and draw a circle where A is going to be the center and C is going to be some point then on the circle. You actually don't really need to draw the circle in this case because we're doing a half turn. So what that means is, according to our definition of how half turn work, you can see that C is going to be, point A is going to be translated onto the opposite side. So let's see here. C is going to be my center. Oh, sorry, I think I drew it wrong. So C is going to be my center. So then that means that we're going to draw this direction. And that means I don't need this guy over here. Where A is going to be on one end, and then that means that the translation is going to be on the opposite side, where this whole thing is going to be like, say, the diameter. So if you need to draw it out, that's totally fine, but I feel like you probably can see it so that the circle looks something like this. So as soon as you turn 180 degrees this way, right, then that is going to be your coordinate then. So that translates into something that's quadrant 3, and it looks like it's going to be -4, -4. Okay. All right, a couple more. Let's see. This time we're going to take point B, and I'm going to rotate it about point C, and we're going to do it backwards to -90 degrees. So go ahead and erase this guy over here. Erase all of this. Erase all of this. Okay. Let's see here. There we go. Okay, cool. All right. So next item. Let's see. Point B is going to be my target. Point C is going to be my center. And so I'm going to go ahead and draw a line segment over there, right? So then that way you can kind of see the circle once again. So the slope of that radius looks like it's going to be -1/3. So that tells me that I should go -1/3 down by 1 and across by 3 over there. So that's going to be the opposite side where that line segment is going to be my hypotenuse. I'm going to rotate it by -90 degrees. So that means I'm going to go in the opposite direction. Now, since you're going by 90 degrees, then that means that the slope, this is where the slope comes into play. Remember, the slope is supposed to be the negative reciprocal. Since your slope from B to C over here, so from B to C, that is equal to -1/3, then that means the slope of the perpendicular is going to be 3 because we're going to go up by 3 and across by 1. So here's the 1, here's the 3, here's the 3, here's the 1. So over there, that is actually going to be the position of my rotation if I were to go backwards. And just to draw the circle, so then that way you can see it. So here is what it looks like then. Okay, so that is going to be the point. This is going to be right angle. And we can again figure out what this point is by going by the coordinates then. So it looks like it's going to be 2, 6. Okay, so that's going to be our answer. All right, now here's the last one then. Okay, so this one is a little bit trickier because we're going to be working backwards. This one, I am going to, and let me see if I can just erase this a little bit more. Okay. There we go. Okay, so this last one, I want to know what is the rotation. Okay, I want to know what is the rotation so that I am going to take point C when I am going to put the center at D, and then you're going to get A as the result. Okay, so first of all, we're going to look at D right there. That is going to be the center of our circle. And then I'm going to take point C, right, which is located right there. So just as usual, I'm going to go ahead and draw the circle that is going to contain point C with D as the center. From there, I am going to rotate by a certain degree. And then the result is that it's going to get me to point A. Well, from there, you can probably see the answer then. So that's going to be this guy right here, which is 90 degrees. So then that means the solution over here is going to be 90 degrees then. But another way of you can look at it is that this, if I were to rotate the opposite direction, that would actually work too. So that means another answer would be -270 degrees. And technically, there are infinite number of answers because for every 360 degrees, you go back to that same position. So, you take your pick as to which one works best for you. Okay. So in conclusion, both of these guys right here, the rotation at point D of 270 degree of point C that is also going to give you A. So these two are equivalent to each other then. All right, thank you so much for watching, and I will see you guys next time. Okay, have a good one. Bye-bye.